welcome you all to our 4th European Green Conference. Unfortunately, because of the pandemic, we have to do this live. Hopefully next year or soon we will have a live meeting again. But thank you for being here on a Saturday, joining us. I just wanted to let you know that my co-chairs for the conference, Gillian, Amela, and Marita, are here with me to welcome you all. And I just wanted to say thank you for being here, and that that we are representing not only the Green to be Europe, but all the European green genes, all the green genes here in Europe. And I want to thank you again for being here. I have a few housekeeping items to discuss. One is that all these conference is being recorded, so please avoid putting any sensitive personal information about your child or family member or whatever in the chat or the Q&A, or at the discuss it at the roundtable discussion. So just keep your questions broad. Post your questions for the speakers and moderators at the Q&A section. So you're going to see on your screen that you have a chat and you have a Q&A. So please, it will be easier for us to just follow up the Q&A section. So if you could please put it there. We will have one of our members, Mustafa, will be actually monitoring also through the Facebook streaming, the questions that will come via Facebook. But if you're joining through Zoom, please do share them through a Q&A. Our moderators, it will be myself and Gillian. And the talks will be recorded for all of us to view later on. And the reason why we record it is we understand that not every family it's fluent and can understand English very well. So we are translating this as we did last year in seven different languages. I will make them public once we have them translated. The program is divided in 4 blocks again. We will have 2 speakers per block except the last block. After each block, we will have a 5 minutes Q&A, and after that we will have a lunch break after the first 2 blocks. In the 4th block, we will have 1 speaker, which would be actually our sponsors, and we want to thank very much Green Therapeutics for the sponsoring us, allow us to have this conference recorded and managed by Calliope and her teammate Gabriela from the Philanthropic Without Borders. And then after the roundtable discussion, we'll just do quick words, final words. Questions in the Q&A that are left. So in the Q&A section that are left that we cannot reach because it's only 5 minutes, we'll try to have them come up at the roundtable discussion. So hopefully all your questions will be answered. We also are posting a survey in the chat and also in our Facebook page. So please, if you can fill it up, this will give us a little bit better idea what the families want in terms of, for our next meeting topics, etc. But also to get, we are a very small group and we're trying to open it up. As I said, we want to broaden it to all green, and we would love your help in any way. So, I leave that survey out there for people to answer, and we're looking forward to your replies. And then as I said before, a warm thanks to our sponsors, Green Therapeutics. And with that, I will give, I'm going right into lunch break. We have a couple, five more minutes to, I don't know if Gillian, you want to say something, Marita or Amela?
Well, I, of course, would like to welcome our participants from all over Europe as well. I'm very glad that you've all signed in to watch our conference today. I think we have a very interesting program with a lot of interesting speakers. including our sponsor, GRIN Therapeutics, whom we are, of course, very grateful to. And I'm really looking forward to this conference, and I hope you all do too.
So I maybe go with a quick introduction of our first speakers. Both Natalia Juliá, Dr. Natalia Juliá, and Dr. Ángels García-Cazorla. I think some of you or most of you know Dr. García-Cazorla. They're both neuropediatricians from the Hospital Sant Joan de Déu, and they are busy studying and learning more about GRIN diseases, disorders. And so today they are here to bring us a quick update on the L-Serine clinical trial, and also to talk about a new project, the GRINscale. So I know we are starting a little bit early, but maybe we'll have a lot of questions after this. So Ángels, I will quickly leave you.
Okay, well, thank you. Thank you so much, Sandra, and all the organizers for inviting our group to talk a little bit about the update on the L-Serine clinical trial that is still going on, and a new project, which is the GRINscale. So as you all know, the L-Serine clinical trial has as main objective to determine L-Serine efficacy for GRIN genetic variants leading to a loss of function. And this study, in fact, was submitted for funding to Nutricia Metabolic Research Fund, which is an open yearly call for grants where many researchers submit different proposals related to metabolic treatments, and our proposal was selected to be funded together with other 4 projects in other very different topics from other centers. So we received a small quantity because it is something that is a research project, in fact, compared to the funding that in general is necessary for clinical trials that are promoted by the industry. So in our case, our hospital, our group in Sant Joan de Déu in Barcelona was the promoter, and we obtained this quantity to have the opportunity to develop this project. So because of these budget limitations, we decided to do the project in Spain only, and you can see here the different regions where the patients have been recruited. And the distribution by gender, age, and mutation, more or less the half of participants are boys, half are girls. And the most frequent mutation is GRIN2B, and then we have an equal distribution between GRIN1 and GRIN2A. So this is the study design that we decided it could be interesting. We evaluated our patients 3 months before starting L-Serine, just to have like a short idea or a brief idea about the development, although in this short period of time during 3 months without the treatment. And then we started regular treatments at different moments over time, and by now 6 children have just ended all the process, so they have finished and the clinical trial, but most of them are now about to complete all the protocols. So in few months probably we will have like the global result of all the project. So these are the scales that we have applied, and all the studies that we have performed over time. And this is something that has been protocolized for every patient. And I will show you only some preliminary results that for sure are unpublished because we haven't finished the study. But what we could see, most of our patients are improvements in different degrees in attention span and also reaction time. And this is very important because attention is an essential function to learn that allow everybody to be focused and learn new things and improve knowledge in things that we already know. Also, all the what we call executive functioning, also we notice improvements, and this executive function is characterized by the capacity to plan, organize, control one's responses in order to achieve a goal. So we have to, I don't know, to write something as a homework, for instance. So we know more or less we have in our mind the time that is necessary to do that. How are we going to do that? I mean, and the also to be motivated and to more or less to keep our attention on doing the same task all the time. So all these things are related also attention to executive functioning. This is something that is very frequently, I mean, it is characterized patients who outside the world of GRIN related disorders. It is very characteristic of children with ADHD, these abnormalities of planning, organizing. So all these executive functions are abnormal. So what would be found also is that there are some achievements that for us are difficult to measure with our current scales, because it is interesting that we found out that children learn to imitate when starting L-Serine, at least some of them, or an important proportion of them. They start to understand the meaning, well, the double meaning, jokes, verbal irony also. They may improve the ability to interact non-verbally using other non-verbal strategies to communicate. And also the sleep quality improves. So this is something that we found like a common finding in the for sleep quality. We have very nice scales, but for other items, it is difficult to register these improvements in the current scales and standardized scales that we have. And here we have some examples that are really illustrative, like this child, 18-year-old child, GRIN2A2 mutation, with this was the writing before L-Serine, and 6 months after L-Serine, you can notice an improvement in the writing, and this is the same for these children here, 14-year-old GRIN2B child with this writing before L-Serine, and at the end of the protocol, 12 months after, the improvement of writing was really also remarkable. It happens also a little bit the same with the quality of drawing that improves. So all these motor functions that are related to the coordination that we need to write and to draw seems to improve with L-Serine. So we had limitations in this study, and this, as I mentioned, a discrepancy between the changes in general improvement that the patients and the teachers also report us, and also verified by neuropsychologists and neuropediatricians involved in the clinical trial, and what the tests are capable of measuring. And this is also because these items that I just mentioned are not very measurable in terms of quantity or of particular scores that can be analyzed and quantified in validated clinical scales. So what about patients from other countries and not only from Spain? So during this time where we were in fact performing and doing this study, we were contacted by many different doctors for not only for the clinical L-Serine advice, but before, and very important for functional studies. Dr. Xavier Altafulla and Mireia Oliveira were contacted first for functional studies, and then depending on that, we shared our protocol, and we gave advice to other doctors that contact us in from different centers, as you can see here in Europe. But not only in Europe, also in other parts of the world. So I think that this is a very rich experience. All the team were just considering that based on all this experience, patients who are followed the same protocol or a similar protocol in different countries of the world could be added to this, to the results of this Spanish series, to have a greater number of cases and therefore a better knowledge regarding the effect of L-Serine. So some of these doctors that are involved, that were previously involved in sharing the protocol and with the functional studies, have already agreed that they will participate in a common study, not only reporting the Spanish patients, but also patients from other parts of the world. And I think that it could be like very rich information for everybody. So what we have learned is that GRIN patients have some particularities that are not properly detected in the conventional scales, the scales that we are using, Venelen, Bailey, IQ test, and others. And we have also learned that L-Serine response may be related to the severity of the clinical symptoms, but we have to analyze that more in detail, because not only in our patients, but if you are going to receive many other patients from other countries and other cities, I think that we have to do like a global study, and then to have the precise conclusions. And that the improvements with L-Serine are sometimes in areas that the conventional tests don't detect properly. This is something that I have mentioned many times, and in particular in imitation skills, making jokes, understanding the double meaning of things, the increase in the game complexity, and also writing and drawing improvement. So because of that, we want to start a new project. We in fact have already started this year a new project, which is the development of a GRINscale, and it is going to be also a collaborative project. So we aim to develop a scale that is as specific for GRIN-related disorders, or at least if it cannot be absolutely as specific, it's going to be very helpful, more helpful than the scales that we have now. There are other examples for other rare diseases that have their own clinical scales, like Rett syndrome or Angelman syndrome. It has been also developed in a group of disorders that are the NBIA, the neuronal brain iron accumulation disorders, which are totally different from these ones. These are disorders that tend to have a neurodegeneration. Rett, Angelman, GRIN tend to be, are in fact neurodevelopmental disorders, are a little bit different. We are now also working in participating in a scale for evaluating infantile Parkinsonism, because Parkinson's disease is very well established and detected with scales for adults, but not for children. This is something in which we are also participating in another working group. So I think that it could be really helpful to have this scale, also not only for particular diseases, but in different environmental settings, like in African rural settings, they have decided to develop their own scale of neurodevelopment, because the circumstances are totally different than in other Occidental countries. So I think that it is interesting to adapt the scales to different diseases and circumstances that are in a particular moment or for particular needs. So this GRINscale will involve a multidisciplinary team with different type of professionals, not only pediatric neurologists, but physical therapies, neuropsychologists, speech therapists, a mathematician who is always involved in this kind of scale development, and also patients. We are asking for your help. So Natalia Juliá and Rosanna are the main people involved here, but for sure, Natalia Juliá, you know, she is an adult and child neurologist and has been involved in all the L-Serine and GRIN-related projects since the beginning here in our group. And then Rosanna, she has started this year with us, but has a large experience in the evaluation of children and also as a speech therapist. And she has also an important experience in research. So I think that the two of them are a very good team, but they are the leaders, we can say that, but then we have all these other professionals collaborating. So we have already performed an extensive review of the medical literature, looking for similar diseases for standardized scales to evaluate different functions. And we have decided we are going to evaluate functions that are related to attention, memory, praxis, which is the motor development of a particular intention, like, I don't know, grasping things, or visual constructive language, communication skills, executive functions, cognition, and in particular the flexibility, the concentration, frustration, tolerability. Social cognition is also something very important, autonomy, quality of life, behavior, motor functions, and this will be for sure age related, because the items will not be the same for a 2-year-old than for a 1-year-old child that for a 14-year-old child. So we will also include non-neurological symptoms, and that scale we aim to develop a friendly scale so that it could be used not only by neuropediatricians, but also by physical therapists and other professionals that are working normally and regularly in the field of child neurology. So this is my last slide. This project has a 2-year duration. So we have started in January 2022, and we have already a draft that has to be a little bit more developed, but once we have an advanced draft of the items to be collected, we would like to share it with the patients, with patient association, because I think that you can contribute a lot, because we will have all the items collected in these different areas that I show you. That this is just a draft. Probably it will be very better organized and with the other different aspects, but I think that you can contribute a lot because you have the experience of your own child. Then once we agree on the items that have to be collected and in which manner, we will have the evaluation of a mathematician who is always a professional involved in this kind of scale development. Then the scale will be applied in Spanish patients because it is easier for us, for the language and for the proximity in person, and also by video conference we can do that. Then the scale will be validated by other neuropediatricians and professionals involved in child neurology in Spain, but then it will be validated in other patients in Europe. We will contact the doctors, physicians who are involved in GRIN related disorders, and that we know because we have previously collaborated with them, as I already showed you. So this is all. This is our project. We probably this will be the second year, the validation in other countries and patients in Europe. And for the first year, we will stay with the. We hopefully we could finish the other stages and the other objectives. And that's all. I would like to thank you very much for your attention, and in particular to the Spanish Association of GRINopathies, GRIN-related disorders, because they are working a lot to help us in the development of this scale and also in many other projects. And so thank you very much. And that's all.
Thank you, Angels. Thank you, Natalia. We'll leave the questions for 12:15. I want to know, well, we actually have a little bit of time, so I don't know if somebody else has because we've gone a little bit faster than I expected, so I don't know if somebody has a question from the audience, if they want to ask any other question. I just want to I want to just make sure that everybody knows that the GRIN, Spanish GRIN Association has managed to raise almost half of the cost of this project, the GRINscale project. And of course, we would love for the European community if, there is an open project right now at the Hospital Sant Joan de Déu. If anybody wants to hear more information about that, to either write to us or we are actually sharing, or we have shared the links to both the Spanish Association and the hospital website, in case anybody would like to donate and, you know, make sure that this project keeps on ongoing. So hope that goes on. So I don't know if anybody, there's a question here. Okay, so I'll just read it. We're in the UK and we haven't yet found a doctor with GRIN experience. Can you recommend any? We would like to get involved in some of the trials, and we would like to get involved with the L-Serine trial in particular. So what would you guys reply to that?
The doctors in the UK who are involved. Mm-hmm. Yeah, if you want, so we have like a list of different professionals that have contacted us and that are involved. And if you want, this is something that maybe we can share with you, because they already agreed to, we can ask them to, if this is possible. I don't think any kind of problem, but for sure, and we can share it with you, with your association, if that could help. We have been contacted by several doctors in the UK. Natalia has all the records, and so if you want, this is something that we can. First of all, we are going to ask to everybody, the patient associations ask for this particular request to distribute a little bit the contact of different professionals in Europe, and then we can share that to the association if you want, so you can have all the people involved.
Good, yes. And you can share that with us or share it in the chat.
Yes, I think so. First of all, we have to ask them if they would like to be involved in that, or to share this information. I don't see any problem. For sure, they will say yes, and then we will send it to you for sure. Yeah.
Oh, we have another question. Okay, you said, this is Alan. Hello, Alan. You said you expect different results depending on the kind of troubles the kid has. Could you be more precise about that?
Yeah, well, the experience that we had so far is that child with, who are less affected with milder forms tend to respond better, or at least we see the changes and the improvements quite fast. During the very first months of treatment, and this comes like very quickly. And in these children who are severely affected, and that implies that the motor function is really involved with, reduced capacity, autonomy for movement, and then the changes come over time and are slower and are that they respond less. This is a global idea that we have, but then we have to then analyze better the results and to finalize also the project, the clinical trial, and then to add the experience of other professionals. I think it could be very interesting.
I have one more question too. I know that at one point we had in one of our conversations with you, the fact of creating like a small group of family members that could act as an advisory, to this project, to help out develop some of these things that sometimes the scales, and even as parents, we notice things that are happening with our children, and we don't know exactly how to explain it in medical terms. And this could be very helpful for us, for example, and helpful for you, because we might detect things that you guys, because you don't live with the child day in, day out, you will not know that we are perceiving these things at home. Small changes, and I don't know if you want to work more. I know this is something that we can consider, in the future, in the near future, to form a group and kind of join you guys.
Yeah, I think I think it's absolutely necessary, and it will be very helpful. What do you think, Natalia?
Yes, I'm saying that it's necessary. Yes.
And one more thing, I mean, in terms of the European, I think we spoke to from this question that we had about, you know, finding a doctor. And I know this is not the first time that somebody comes to us and asks us. I think it's important to start building a network. And we kind of start that with the initiation of the L-Serine trial. But I think, you know, this is something that, again, as association, we can help, you know, create more of a European network of doctors, and you know, and how we can work best with you and with everybody else. No, that whatever it's being done, there's information traveling from one doctor to the other. So I don't know how you guys see it.
I think this is something to be done, and it is very important. And in particular, if we have your support, I think that it is something that really will help. Yeah. Yeah, sure. We should work on that.
Thank you. Yep, I have one more. What after the trial? So do we have anything else? Is it possible for families to continue with L-Serine? Does Nutritia continue with the distribution?
Yeah, this is a very important question. But I guess, well, I think that it will depend, like always, on the policy in different countries. I mean, in Spain, there is no problem. We can still continue with the prescription of L-Serine from our centers, because it is a medical food that is authorized to be covered by the public health. So there is no problem. But then I don't know how is the regulation in other countries. I think that if the results of the clinical trial are supportive, it will contribute that in different countries, wherever the country, it could also have the same status as we have, and that it could be considered as a medical food that is necessary for this disorder. This happens very, so the example that we have is in the inherited metabolic disorders, where they need a specific diet or a specific supplements, because it has been demonstrated over years that this is really the treatment of these disorders. All these things are covered by the public health system in all Europe, that there is no problem at all. But then, because this is something new, we have first to demonstrate that its usefulness, and then to establish like the correct distribution and the fair distribution among all countries in Europe. I think that also your help will be very supportive in this case. But well, let's wait for the results of the whole clinical trial and the evaluation of different patients in Europe, and then perhaps this is something that can help to distribute L-Serine in this manner.
I'm not sure if Sandra, she disappeared from the screen, but there's another question. There was a question in the chat from Rob, and he asked whether there have been any adverse reactions to the L-Serine.
There have been a couple of children with adverse reactions. So one children had an increase in irritability and behavior. She had previously some behavior abnormalities that impaired with treatment. At the beginning, the first 2 weeks, she was better and in attention and everything, but then she started to have more irritability and restlessness, and the patients decide to stop the treatment. And then we have another patient with some digestive symptoms that finally disappeared. Yes. So these are like the two, yeah. Yes. But in most cases, yeah.
For the first patient that Angels told, it's true that this patient has a high dose of L-Serine because it's a big child, and he received high dose. Maybe that's why she has that irritability and insomnia. Yes, but parents prefer discontinued the treatment. And for the second patient,
because, well, the advice would be to slow down the dose, no, to have a smaller dose, but then the parents decide suddenly, well, we are going to stop, and we didn't have the opportunity to see with the with the lower doses who was.
Yeah. And I think also it's worth mentioning that before anybody tries L-Serine, there needs to have a proper functional analysis done. You know, we ran into a scare point. It was a few months ago that a family ended up wrongfully using the L-Serine. And yes, I mean, the L-Serine, even though it's a nutraceutical, it's given at such high dose that could have side effects like anything else. So I think this is important to remember, not self-medicate, not, you know, be sure that you have the right, you know, answer. And yeah, I mean, like everything, we need to be very, very careful. I had one last question about the dosing, which is what Natalia was talking about. I know that this trial was focused on the tolerability of L-Serine, and it was at a dose that it's basically what the dose that has been given in the past, and it seemed to work and everything. But is it expected to plan maybe a dose trial or just trying different doses for those children like this child, you know, that didn't respond well? Because we might, you know, without wanting to, you might eliminate a product that could help your child, but just at a much lower dose than what it's recommended. And I don't know.
Well, this is an important point. I think that, yeah, it needs probably another study, a different study, just to see if the effect is sustained with lower doses than we are given now. But probably what we are going to do in our clinical practice is to adapt the dose to every patient. And in particular in those patients who are older and the weight is important, then we cannot use the same recommendation of between 400 and 600 milligram per kilo per day, because it represents a very high amount. So probably then we have to go down up to 200 milligram per kilo per day. This is very similar to what has been done in primary deficits of synthesis, of L-Serine synthesis, which is another different type of disease, and a metabolic disease in which the enzyme that is necessary, there are different enzymes necessary to synthesize, to produce in the body, L-Serine. And when these enzymes are not working properly, we give this L-Serine, and the study was based on that, and on the use, the safe use of serine was based on that, because for a long time ago, we use L-Serine to treat these rare diseases. So in adult patients, they use like 200 milligram per kilo per day only, and even less than that. Whereas in children, the correct doses goes up to 600 and even 700 milligram per kilo per day, starting for 400 until 700 milligram per kilo per day.
We have two more questions. I think that the second one, I can answer that, Matthew. For Tina, she asked if the patients that stop taking L-Serine, do they, you know, she heard or somebody mentioned that they could regress. I just quickly want to make a point that my daughter has been on L-Serine for a while, on and off. And she's never regressed, put it this way. No, regress, no. The thing is, you notice that, you know, it just, when you give it again, you notice a difference. But I'm talking about personal experience, but I don't know, Angels, you've made this experience.
No.
Okay. So, and Matthew wanted for us to share, and I don't know if you guys have it handy, to share the clinical trial information. I think you had it at the beginning of your talk, and if not, we will share it. I know that
it is published in the clinical trial page, so it's available, publicly available. Yeah,
exactly. So. Well, I know we're a couple minutes late, but I know that Laetitia is already with us. So if you guys don't mind, I mean, if there are any other questions at the Q&A, we can follow the discussion. But if not, I think I'll give the the floor to Laetitia. Thank you very much for joining us from France. Laetitia is a researcher at the Institut de Pharmacologie Moléculaire et Cellulaire de Valbonne, France. And she would talk to us a little bit about, well, a little, no, probably a lot about microbiota, the brain-gut axis, and in neurodevelopmental disorders. So thank you very much for joining us today.
You're welcome, you're welcome. So I will share my screen. So thank you very much for inviting me to present you a little seminar on the microbiota gut-brain axis in autism spectrum disorders. And special thanks to Chabi, who actually invited me. So as Sandra said, I'm a CNRS researcher. And I wanted to tell you that for 10 years, before 2015, I've been working on a single genetic disorder called Fragile X syndrome. So I'm a bit familiar with genetic disorders which cause neurodevelopmental defects. But since 2016, I'm interested in environmental factors which can contribute to neurodevelopmental disorders. And that's how I became interested in understanding how the microbiota as an environmental factor can contribute to neurodevelopmental disorders in general, but also autism more specifically. Okay, so just a few words about the microbiota first. So on the right side of the screen, on the left side of the screen here, you see it's an electron micrograph of the microbiota in the gut, sitting on dietary fibers. So from this micrograph, what you can see is that there is a great diversity in terms of microorganisms which constitute the microbiota. And also that we have a lot of microorganisms lying in our gut. And what we call the microbiota is the ecological community of commensal, symbiotic, and also pathogenic microorganisms which inhabit our gut. And roughly in adults, we have around 2 kilos of microorganisms lying in our gut, and a number of key factors actually influence the composition and the diversity of our microbiota, and notably the age, the sex, our diet, and our food diversity, but also stress and environmental factors. So when we think about the microbiota, we think a lot about bacteria, but you have to know that there are other types of microorganisms which constitute the microbiota, and notably what we call the archaea. And the archaea are, for many of them, methanogen. We have also fungi, we have viruses, and we have, of course, bacteria. We have above 40 billion of bacteria in our gut, and to date, roughly 7,000 strains have been identified, but we know that there are many unknown species of bacteria which inhabit our gut. And some of the bacteria you may know, Escherichia coli, Bifidobacterium longum, or Lactobacillus acidophilus. So how our microbiota does develop? Well, the intrauterine environment is sterile, and initial colonization occurs via the mother at delivery. And the mode of delivery, meaning C-section or natural delivery, will directly impact the type of microbiota which is transmitted by the mother to the newborn. And also perinatal antibiotic treatment can also modulate the microbiota, which will start to develop right after birth. And then when the type of lactation for the newborn is also important, because breastfeeding against feeding the child with formula milk will also impact the microbiota composition. And when solid food is introduced, Also, the diet of the child will determine the microbiota composition. And of course, the more diverse the food given to the child is, the more diverse the microbiota will be. And then by adolescence, the composition of the microbiota actually stabilizes and resembles mostly the one we will have during adulthood. And what we know is that environmental factors are key for microbiota composition. And we know also that unbalanced or misadapted microbiota is present in a number of pathologies in humans, and not only metabolic disorders such as obesity or type 1 diabetes, but also autoimmune disorders such as asthma or IBD. And recent work has also shown that pathologies impacting the nervous system, such as depression, bipolar disorders, schizophrenia, hyperactivity, or even autism, are accompanied by changes in microbiota composition. So it means that in those pathologies, we have an imbalance between the pathogens and the symbionts within the microbiota, because it's always a trade-off for microbiota composition between the good and the bad bacteria. So among the good bacteria, you have the bifidobacteria, you have also some strains of Escherichia coli, you have lactobacillus, bacills. And among the, let's say, pathogen or less good bacteria, you have Campylobacter, Enterococcus faecalis, for example, and also Clostridium difficile. And you can understand that if your microbiota is in imbalance, it means it will not be able to accomplish its function within the body. So until recently, the main functions we thought that were for the microbiota were first to promote digestion by facilitating the absorption of nutrients, two, to help the digestive tract to function properly and controlling the motility and the progression of the nutrient within the GI tract. And also a healthy microbiota actually creates a barrier between against pathogens and toxins which are present in the lumen of the intestine. And also a healthy microbiota plays a defensive role in the development of the immune system, because it will actually educate the immune system and teach him to recognize beneficial versus harmful bacteria. But over the years, we also realized that the gut was also connected to the brain. And I think you've heard about what we call the second brain. It means that the gastrointestinal tract is densely innervated. We have above 500 million of neurons in the gut, and they are very important to control the gut motility and so on. But they also sense the luminal environment and the gut environment and relay information to the brain, notably by using a very long nerve, which is called the vagus nerve, and which collects information from the GI tract and relay it to the brain. Also, what we, and this is called, let's say, the gut-brain axis, but I think we should nowadays more talk about the microbiota gut-brain axis, because we now realize that not only does the enteric nervous system present in the gut communicate with the brain, but the microbiota is able to actually modulate the function of these neuronal pathways which connect the gut to the brain. And we also know that the microbiota is able to modulate at the level of the gut the immune system, and notably the secretion by immune cells of small molecules which have signaling properties and which are called cytokines, and which can actually reach the brain and modulate brain function directly. The microbiota is also able to control the secretion of specific hormones and neuropeptides by cells, which are called neuroendocrine cells, and which are lying within the gut barrier. And these neuropeptides can also directly act on the brain. And then there is an emerging route of communication, which is via what we call microbial metabolites. So these are very small molecules which are produced by the metabolism of bacteria from the microbiota. And quite interestingly, those metabolites, they can circulate in the whole organism, and they can act either locally in the gut on the different cell types I talked about, but they can also eventually reach the brain. Some of them have been actually detected in the brain. And we know that this is really critical, this communication between the microbiota and the brain via these different routes. And we also suspect that in a number of neurodevelopmental disorders, including autism spectrum disorder, there is a deregulation of this microbiota gut-brain axis. So now I'm going to talk a bit more about autism spectrum disorder. So it's frequent neurodevelopmental disorder. The latest estimates are relate an incidence of 1 out in 100. And ASD patient exhibits core symptoms of social communication deficits, repetitive and behaviors and restricted interest associated with abnormal sensory processing. But you have to understand that ASD is a very complex and heterogeneous pathology, because not all patients express the symptoms with the same severity, with the same degree of severity. And the clinical picture is also complex, because ASD patients frequently exhibit either neurological or psychiatric comorbidities, such as seizures for neurological comorbidities, anxiety, hyperactivity disorder, language disability, intellectual disability. And they also exhibit somatic comorbidities and notably immune dysfunction and gastrointestinal disorders. Regarding ASD causes, as I said, it's a complex disorder which is multifactorial, and there are very strong interaction between environmental and genetic factors. So regarding genetic factors, we have above 1,000 genes which have been associated with ASD, including the GRIN genes, GRIN1, 2A, and 2B. There are also copy number variants, namely deletion or duplication in certain loci. But today, genes only explain 20 to 25% of ASD diagnosis. And we really believe that there is a strong influence and environmental factors which interact with individual genetic susceptibility and leads to the development of ASD in certain individuals. And among environmental risk factors which have been described for ASD, we have C-section delivery, in utero exposure to environmental pollutants or drugs, to maternal obesity or to maternal immune activation, meaning infection or autoimmune disorder during pregnancy. And quite strikingly, all these risk factors impact either the antenatal or the perinatal period, and they are all known to modulate microbiota composition. This is why also several researchers have tried to analyze the microbiota composition in ASD patients, and there are dozens of studies which addressed this. Unfortunately, there is no clear consensus regarding to the taxa or microbial taxa which are impacted, because studies have been designed differently, and it's difficult to make sense out of all of this. But recent meta-analyses have shown that apparently there would be a loss of certain beneficial bacteria in ASD patients, or at least in subtypes of patients, with a decrease in bifidobacteria, and increase in potentially harmful bacteria such as Clostridium. And this is accompanied by abnormal levels of microbial metabolites, so the small molecules produced by the microbiota, in the urine serum or feces of ASD patients. And beneficial metabolites are generally decreased, for example, short-chain fatty acids or vitamins, which are synthesized by the microbiota. And potentially harmful metabolites are increased, at least in subtypes of ASD patients, and for example, p-cresol. But then the question arising is microbiota dysbiosis a cause or a consequence of ASD? So some researchers have tried to investigate this. And what they have noted is that children with ASD have 5 times more feeding problems than neurotypical peers. And also mealtime is often a challenging time of the day for ASD patients because of strong food selectivity and a severe bias towards strong preferences for starches, snack foods, processed foods, and a bias against fruits, vegetables, and proteins. So this means that many ASD patients actually have micronutrient deficiencies, which is actually due to their poor diet. And a recent Australian study has looked at the microbiota of 19 ASD patients and 50 siblings and 97 unrelated controls. And they actually concluded that the microbiota of ASD patient was not so different from the microbiota from their peers. However, more severely impacted patients, meaning patients with stronger autistic traits, had stronger dietary preferences. And this was actually what drove the changes in microbiota composition. So severe autistic traits led to strong dietary preferences, a reduction in the dietary diversity. And this led to an impoverishment of the microbiota and a less diverse microbiome. And this was directly connected to stool consistency. And this is a proxy for actual GI symptoms because diarrhea is a symptom which is often observed in ASD patients. And if we look deeper in gastrointestinal symptoms in autism spectrum disorder, and notably looking at a meta-analysis which combines the results of 15 studies starting from the 80s, it is clear that children with ASD experience significantly more general GI symptoms, 4.4 times more, and they have 4 times more constipation, 4 times more diarrhea, and 2.5 times more abdominal pain than neurotypical peers. So apparently GI symptoms are really present, at least in subsets of patients, and they could contribute to impair their quality of life, everyday quality of life. Also, some reports, there are some reports of increased intestinal permeability in ASD patients, and this leads actually to an abnormal porosity of the gut barrier and potentially harmful molecules which should stay in the lumen of the gut, because of this increased permeability, could reach the general circulation and also potentially contribute to GI symptoms in ASD patients. And a lot of ASD patients have reported increased sensitivity to dietary antigens such as casein, lactose, or gluten. So this means that aside from behavioral issues which are present in ASD patients, gastrointestinal issues, feeding disorders, increased sensitivity to dietary antigens are very present in ASD patients. So why is it important to actually monitor GI symptoms in ASD patients? And I think in any neurodevelopmental disorder, and it's because some authors have related actually self-injurious behavior and aggression in ASD patients, with the possibilities that these patients presented GI symptoms, but they were unable to communicate relating to their pain or discomfort. And this could contribute to those challenging behaviors. And also, more generally, underlying GI problems in ASD patients could actually exacerbate the behavioral impairments. And this is really also supported by a number of studies which has shown that the severity of GI symptoms was associated with the severity of ASD-related symptoms, and notably the severity, well, sensory overresponsibility, more severe anxiety, and also social withdrawal. So this said, why is it important to monitor GI symptoms? Because it's important to detect children which have GI symptoms and possibly functional gastrointestinal issues. And also because maybe if we target those symptoms, or if we target the microbiota, maybe we could help them at least to relieve the GI symptoms, and maybe this could help also alleviate some of the behavioral symptoms. So how can we actually target the microbiota or GI symptoms to possibly improve ASD behavioral symptoms? Well, there are several options. So we could use prebiotics, which are actually compounds in food that induce the growth or activity of beneficial bacteria. We could use also probiotics, which are the actual microorganisms consumed for supposed health benefits. We can also use fecal microbiota transplants, laxatives to improve constipation, for example, and also dietary or nutraceutical intervention. So this panel of options has already been explored by several clinical trials in the context of ASD. And but many of these trials were non-conclusive or not of sufficient quality, as really highlighted in this recent meta-analysis, because they looked for the different studies which are addressed different options to target GI symptoms or microbiota in ASD symptoms. So as I identified above 4,000 publications, so meaning 4,000 studies, but only 14 met the inclusion criteria regarding their quality, the number of patients which were actually enrolled in the study design, and also the statistics. And based on these results, their conclusions are that apparently the use of probiotics do not confirm the supposed beneficial effects of probiotics on ASD. However, prebiotics combined most of the time with a specific dietary intervention, and notably exclusion diet, appears to be efficacious in selective behavioral symptoms. And also the benefit, the effect size is most of the time quite small. Then this meta-analysis also highlights that evidence for the efficacy of fecal microbiota transplantation is scarce, but supports further research. And this is why I'm going to talk a bit more about this fecal matter transplantation. So currently, you have to know that this procedure is only clinically validated to cure recurrent infection with Clostridioides difficile. This is the only clinical indication to use FMT routinely. As far as ASD at the moment, it's the subject of clinical trials which have been performed under ethical approval and in a clinically controlled environment, but this is not something which is routinely used. So when you want to set up a fecal microbiota transplantation, how do you do that? Well, the first step is to prepare a high quality microbiota transplant. So this is done by collecting stool from a neurotypical donor. And of course, this donor has to be rigorously screened in order to be sure that the microbiota is of the highest quality, is not harmful, and so on and so on. So there is a thorough review of medical history. We check that there is no GI disorder in this donor. There are serological examinations to screen for infectious disease, stool examination, and also microbiota sequencing to make sure that this microbiota is the healthiest as possible. Then there is another step in which you have to prepare the patient to remove its endogenous microbiota. So this is done by a combination of laxative, stomacal proton pump inhibitor, and also antibiotic cocktails. And this has been done to be done in clinical settings, of course, to constantly monitor how the patient actually reacts to this preparation. And then comes the day of the actual fecal microbiota transplantation. And this can be done by two routes, either an oral route in which the microbiota transplant is diluted in juice, chocolate milk, or even provided as freeze-dried capsules. And there's also via the rectal route, and it will be done by a colonoscopic enema. So once the procedure, the FMT procedure is terminated, we have to allow a few days, weeks for the new microbiota to colonize the GI tract of the patient. And we start performing the longitudinal assessment of the benefits on GI or behavioral symptoms. So this has been done in this study, which is the first to report the use of FMT to treat ASD, and it was published in 2017. So it's on a small number of patients, 18 ASD patients with gastrointestinal problems. And quite strikingly, the authors have been able to actually follow the patient until at 8 weeks and 2 years post-FMT. And what they found is a drastic reduction in the severity of gastrointestinal symptoms, and a reduction also in ASD global symptoms, and an improvement in the social behavior deficit which were present in the patients. And the benefits last up to 2 years after the FMT. So this is rather encouraging, because these benefits were observed for 15 out of 18 patients, and none of the patients actually reported adverse event following the FMT. But this was only one study. So a second study came out last year, at the end of the last year. So it's a Chinese study this time, and they basically, on 40 ASD patients, again with gastrointestinal problems, they also report a reduction of the gastrointestinal symptoms, of ASD symptoms, and an improvement in social abilities, even though the effect size is not as strong as in the previous study. But currently, there are several clinical trials which are ongoing to assess the efficacy of FMT in ASD patients, and these trials are performed on bigger samples of patients, above 100 patients in most of the clinical trials which are ongoing at the moment, because we really need to assess safety, tolerability, and efficacy of FMT in ASD patients. And then I also mentioned in the possible options, it was to use a laxative, specifically for patients which have chronic constipation. So one small study published last year actually recruited 21 patients with chronic constipation. And for 6 months, the patients were administered with polyethylene glycol, which is a laxative. And they assessed stool consistency at 1 month and 6 months post-treatment, but also a number of scales related to ASD symptoms. And it appears clearly that by 6 months of treatment, there was an improvement in stool consistency. And also there were decrease in most of the ASD severity scores for all the scales which were actually administered to the patient. So this is quite interesting, because it shows that simply by actually stimulating the gut transit, it apparently improved not only the gastrointestinal symptoms, but also some of the behavioral symptoms, and eventually the quality of life of the patient. And then one last option mentioned earlier is to use nutraceutical and dietary intervention. So there are many studies of this kind in the context of ASD, but most of them are on small number of patients. They are not well controlled, and the statistical design is not accurate, meaning that they are not so reliable. So this one is apparently to date the most complete study which has been performed. So it concerns 37 patients which have been treated and 30 untreated. And the treatment was quite complex. It lasts for 1 year, and it consists in sequential supplementation with various types of nutraceutical supplements. So first are vitamins and essential fatty acid supplementation, Epsom salt bath combined with Epsom salt bath, then carnitine supplementation with digestive enzymes, and finally, by 6 months after the beginning of the treatment, they switched to a healthy, casein-free and gluten-free diet. So it was a quite constrained dietary intervention. The symptoms of ASD were assessed at baseline before starting the treatment, and then after 1 year of treatment. And quite interestingly, there is an improvement in most patients which were treated on most of the scales which have been addressed, and scales specific to ASD, but also scales related to developmental delay and so on. So this really provides hope and sets ground for further studies using this kind of dietary supplementation. So in conclusion, so what we know so far is that gastrointestinal symptoms impair everyday functioning of ASD patients. Environmental factors and food selectivity explain part of microbiota dysbiosis in ASD patients. And targeting the microbiota or GI symptoms seems to be a valid therapeutic strategy. And what do we need now? We need more functional studies to assess actually the function of ASD-associated genes in the GI tract, because so far these have been very poorly explored, and it's possible that genes which cause dysfunction at the central level, for example, dysfunction in the synapses, they could also cause dysfunction in the GI tract and contribute to microbiota imbalance and GI symptoms in the patients. We need also more clinical trials, adequately designed, adequately powered, and to assess the efficacy of microbiota intervention in ASD. And also, and I think that's really something which should be pushed forward, we need to better characterize microbiota dysbiosis and gastrointestinal symptomatology in each patient, because there is not one patient which resembles the other. And this could allow to propose more adapted and more personalized therapies, because of course, if you have a patient with chronic constipation and another one with chronic diarrhea, eventually you will not provide the same treatment option to both patients, because their symptomatology is really different. And I thank you so for your attention, and I'm ready to take any question.
Thank you very much, Laetitia. That was actually a fantastic talk. I really enjoyed it.
Thanks, Sandra.
We have one question here. Let's see if we can answer it. Our son has 2 positive FMTs 4 years ago from Clostridium difficile, and he improved a lot. But recently he has had lots and lots of antibiotics, and his bowels are awful again. Would you recommend another FMT even though C. difficile is not present?
The thing is, as I said, so FMT is allowed in clinical settings for Clostridium difficile recurrent infection. So that's what you did. But then I'm not entitled to recommend or not recommend. You see what I mean? But what you're telling me is that after the FMT, you had improvement, of course, I guess, in the GI symptoms, but also maybe in behavior, but because also maybe your kid was really really feeling uncomfortable undergoing a lot of pain, and maybe was not really able to communicate related to this. So of course, if you cure the GI symptoms, you somehow help him to lower the behavioral symptoms. Then, so as I said, I'm not entitled, and I don't feel like I cannot advise you to try another FMT or whatsoever, but I think that if there are really strong links between GI symptoms and behavioral symptoms, GI health, and actually behavioral and central nervous system health, of course, the two should be treated at the same time and should be considered.
And I would imagine also try to start wondering, why are we giving so much antibiotics to get that way? And this is something I wanted to ask you, because FMT, at least at the animal level, I mean, when they've done FMTs and then and you keep on feeding the same things, you might actually revert back to your original gut microbiota, just because of the same tendencies that you said, especially in kids that are very selective with the food. So even if you do an FMT, which is quite a procedure, I mean, it's not an easy thing. I mean, it's something that requires probably anesthesia in our kids and other things that are, you know, increase the risk for other things to happen. I think the FMT is kind of like the last resort, like you said, you know, for something really serious, like the difficile infection. But what I'm saying is, once you have the FMT, you might revert back to the bad bacteria if you don't do dietary changes. You know, what is it that, you know, maybe this is what you need to do, like a combination dietary plus FMT.
A bit as what I was commenting, you know, the nutraceutical and dietary intervention at the same time. And I think that by combining different approaches, that maybe you will have the more chances to have something more efficient. I think you're right. And it's true that you can provide a new microbiota by performing the FMT, but if the dietary, the diet is not changed or adapted, I think that the beneficial effects of the new healthy microbiota will wane away, because you have to maintain this healthy microbiota to be sure that the beneficial effects actually last. But it's true that in the paper I commented on the FMT in the 18 ASD patient, it's not really clear whether they were actually given specific advice regarding their diet and so on after the FMT. But the FMT procedure took quite a long time, especially from one arm of the clinical trial and so on. But and I think that really, if an FMT is programmed or decided, or if the kid is enrolled in a clinical trial trying to assess the efficiency of FMT, I think that the parents should be really well trained to actually adapt maybe the diet after the FMT, and to try and provide a more diverse diet afterwards in order to maintain the healthy microbiota and so on. So I hope I'm answering a bit your question.
Yeah. Thank you. I have another question about how do we find out what our gut microbiota, if our child's gut microbiota is varied enough?
Yeah, that's a difficult question, because you know, you can send out stool samples to companies, and they will, well, they claim that they profile your microbiota, and then you can get like an idea of the panel of bacteria which are present in your sample and so on. But then the thing is, even in healthy individuals, you have a great heterogeneity in terms of diversity and composition and so on, so on. So when I think it's important to be able to compare the data from each individual to like really a big group of controls in order to see whether there are really strong differences, and it's not like just random, just because the group of controls to which the results are compared was like biased in a way. And I think it's a very complex question. It's not as simple as when you want, for example, to have a genetic assessment. So you send out your sample, and then they can tell you, well, you have this mutation in this gene, and this is 100% sure. And you know that mutation in these genes are associated with later diagnosis or this or this. For the microbiota, it's not as simple because of its complexity and its diversity. And I know it's we would like sometimes to have like a clear answer, like, is my microbiota really dysbiotic? Which bacteria am I actually missing? Can I actually provide these extra bacteria which are missing? And it's a difficult question to answer.